Every year, thousands of young minds compete at the FIRST Championship, the largest and most prestigious competition of its kind. FIRST, or for Inspiration and Recognition of Science and Technology, was founded by inventor Dean Kamen to inspire young people's interest and participation in science and technology.
Not a bad shot.
The problem is that so many kids grow up in an environment where by the time they're 10 or 12 years old, they think their options in the world are being in the NBA or being in Hollywood. That's their perspective of the world. It seemed to me that what we needed to do to get FIRST going was to break the stereotypical mindset given to kids about what's important in our culture. 10 or 15 or 20 years from today, some kid in those stands will have cured Alzheimer's or AIDS or cancer or built an engine that doesn't pollute. Somebody sitting out there is going to win a Nobel Prize, and they're going to be asked, what made you go down this road? The probability that one of them is going to do something spectacular that they would not have done without FIRST is almost a guarantee. Look at these kids. They're the future. We're part of it by helping them figure out what to do with their lives.
Welcome to the 2009 FIRST Robotics Competition and this year's game, Lunacy. Lunacy is played on a 27 by 54 foot field known as the Crater. Alliances of 3 teams each are positioned in bases at each end of the field from where they control their robots. Additional player stations are located along the edges of the crater. The crater is covered with a slick polymer material called regolith that provides a unique surface for the robots to drive upon. Special wheels are used on the robots to create a low-friction interaction with the regolith. This simulates the low traction effects of driving in the 1/6 gravity on the surface of the moon. Lunacy uses 3 types of game pieces known as moon rocks, empty cells, and supercells. A trailer is attached to each robot. The trailers are the targets for the opposing alliance. The objective of the game is to get as many moon rocks and supercells into the opposing trailers as possible. At the start of the game, human players known as payload specialists are positioned in the outpost stations. Each robot is placed on their launch pad with the trailer touching the wall of the crater. Robots are able to start the game with up to 7 moon rocks in their possession. During the autonomous period, players in the corner fueling stations and the outposts attempt to launch moon rocks into moving trailers. Each robot starts in a launch pad in front of an opposing player. As robots start to move away, the other alliance may try to block the robot's progress to make them easy targets. Or, robots may use their cameras to track the vision targets on top of each trailer. This allows them to track and score in the opponent's trailers. At the end of the autonomous period, human pilots step forward to take the controls. During the tele-operated period of the game, pilots guide the robots as they attempt to launch moon rocks into the trailers of the opposing alliance. Meanwhile, human payload specialists will also attempt to score moon rocks into passing trailers. Robots can also recycle game pieces back to the payload specialists. With a low-friction playing surface, robots will slide easily and high-speed collisions will be common. Bumpers are necessary to prevent damage. The outpost payload specialists can also deliver special empty cells to their robots. The robots then deliver these empty cells to their fueling stations. At the fueling station, the empty cells are exchanged for supercells. During the last 20 seconds of the match, humans or robots can score bonus points by getting supercells into opposing trailers. Each scored moon rock or empty cell is worth 2 points, and each supercell is worth 15 points in the game. Good luck, and we'll see you at the competitions.